Let's continue with some applications of electrolysis. The main applications, and we use it widely in the real life, it's metal refining and electroplating. They have the same concept of electrolysis, but we do some modifications in order to get benefit of electrolysis. Here, in metal refining, I'm going to purify a metal. How can I do this? I'm going to put a pure metal here and the impure one here. The impure one is connected to the positive terminal. Why? The positive terminal always, it's the anode part. On the anode, I'm going to have what? Oxidation. It means this part is going to be oxidized. What's the meaning of oxidation? If we have metal here, the oxidation of it, it's conversion of it into the ionic form. So I'm going to free up my metal from the impure metal into my electrolyte, and the electrolyte should be from the same type of the metal that we are refining. So assume we are having iron, okay, and here I will put a pure iron bar, okay, pure iron bar. Okay, so I have impure piece of iron and I need to purify it. I will put this impure piece on the anode. It means I will connect it, this part, to the positive terminal of the battery, and I'm going to put the pure bar on the cathode. Okay, what will happen? This ions, they are going to be oxidized. Let's write the equation for oxidation of iron and assume it's iron plus 2. So iron is going to be dissolved and ionized to give iron plus 2. Those ions, they will move through the electrolyte until they reach what? They reach the cathode, because the cathode is negatively charged. So at the cathode, the electrons that they are lost, they will start their movement through the wires like this, okay, until they reach the cathode. On the cathode, the iron plus 2 ions, they will what? They will accept or gain those electrons in order to be reduced. So Fe plus 2, they will accept the 2 electrons in order to be reduced on that bar. So after doing that refining, at the end I will see what? Deposition or increasing in the size of that bar, because the ions, they are what? They are reduced and they are deposited, they are going to settle down on that bar, okay, after going into reduction. Okay, so all the time you have to put the impure metal on the anode part in order to be oxidized. They will move through the electrolyte until they reach the cathode. On the cathode, they will accept the electrons through the wires and they will be reduced again on the surface of the what? Of the pure metal. Okay. The other application is electroplating. What's the meaning of electroplating? It's coating a subject with other metal. Okay, I can do this by putting my plating metal on the anode and putting the object on the cathode, and I'm going to put an electrolyte from the plating metal. Okay, assume this is silver, Ag, and this is copper, and I need to coat this star with a layer of silver. Okay, how can I do this? Silver is going to start what? Start oxidation. Why? Because it's connected to the positive part. It means it's the anode. So I'm going to have oxidation on the anode until we produce what? Silver ions. Those silver ions, they will start swimming through the electrolyte until they reach what? The cathode. The cathode is negatively charged. At the cathode, the electrons that they lost at the beginning, they will start their movement through the wires until they reach the cathode. At the cathode, Ag plus will accept electrons again, and they will be converted into what? Into the neutral form of silver, and they will start coating that star. You have to pay attention. In that type of electroplating, you have to keep rotating your object in order to make sure all of the sides are covered with the metal, and you have to clean up your metal before starting the electroplating with sandpaper or with hydrochloric acid to make sure you have what? You have a clean object and there is no impurities that will prevent the electroplating. That's it for all electrolysis. You have to know all of these points, guys. If you have any question, don't hesitate to ask me. Thank you.